Our first question on chapter 9.1 asks, says the criminal justice system wants to know about repeat offenders. They gather 1,000 ex-cons who were released 2 years ago and who have not been arrested since then. The court wants to know how many ex-cons have committed felonies since their release. Of course, none of those present would want to answer such a question truthfully. The interviewer asks everyone in the room to secretly flip a dime. Then he asks them to raise their hands if they flipped a head or committed a felony. 620 people raised their hands. Estimate how many ex-cons committed felonies since their release. To receive credit, you must clearly show all work leading to your conclusion. So here's kind of the explanation of this. So it says if the coin lands heads up, you raise your hand. So if you flipped your coin, it's on a head, you raise your hand. If it lands on a tails and you have committed a felony, you also would raise your hand. Okay, so there's two ways you're going to raise your hand. Either you landed on a head or you landed on a tail and you have committed a felony. So what that does is it splits our data in half. Okay, approximately 500 of these people are going to flip a head. Sounds kind of bad. They're going to flip a coin and it will land on head. There we go. That sounds better. Okay, so just based on 1,000's pretty high number, we should expect around 500. A few lower, a few more, but right around 500. With that being said, since we had 620 raise their hands, that means 120 out of the 500 tails raised their hands, because we should have only had 500 that raised their hands because they flipped a coin that landed on heads. And out of those that flipped their coin that landed on tails, 120 of those raised their hand because they had committed a felony. Okay, so if this group that had tails, 120 of them committed a felony, most likely the same amount out of this that flipped 500 would have flipped a felony as well. And so total we would have 240 people that had committed felonies out of this 1,000. That's kind of what it says going on down here. So if no one had committed a felony, we would expect 50% of the hands to be raised. If, say, 40% had committed a felony, we would expect half of those 40% to have flipped a tail and raised their hand. So now 50 plus 20% would be 70% of the people would have raised their hands. So at 70%, we would expect a 40% rate for those who have committed felonies. So much like what I just set up here, we take this number, this 120 that was above what we would have expected for just pure heads, and we double it because this was 120 out of those that just had flipped tails. We're going to assume that the same amount, same proportion out of those that had flipped heads also had that. So anyways, that's kind of our assumption, and that's how we would end up with, we would say 240 people have committed felonies since their release. Now the next question says, to find out how many students are unhappy with the dining hall food, you distribute a survey at the diner line. What possible bias could result in your data? Well, if you're distributing the survey in the dinner line, that means that you're distributing it to people that, one, they can't go anywhere, so they can't leave, or they like the food. Because otherwise they would have left. If they don't like the food, they leave. Right? I mean, if you don't like the food, you're not going to stick around. You leave. And so we're creating a bias because either these people are stuck here or they like the food. We haven't even talked about the ones that left. They probably don't like the food. And so we're creating a bias in that. The other bias is we're giving it to them in the line, and we probably have said, if you want to eat, you need to do this survey. And so they're like, okay, just let me hurry and do it. And they just hurry and fill it out without being too worried about it or anything like that. So anyways, those are a couple thoughts on the bias that we're creating. The next, underneath that in the pen, it says, how would you create a survey to find out the average GPA of students at MHS, Central Utah, all of Utah, USA? So um, if you're going to take a survey, you can't just email it out and hope that it comes back, because if you do that, people are, the ones that have a good GPA are going to send it back to you. Those that don't, they're going to be like, I'm not going to do this. I don't want people to know what my GPA is. So what you need to do is you need to randomly pick people out of each school. So you might pick out of MHS. You might just say, I'm going to go through the student list, and every fifth person, I'm going to randomly select their name. Okay, or I'm going to go. So say we're doing it Central Utah. I'm going to randomly pick um, every 20th senior. Okay, so I get my list of seniors and I pick 20, 40, the person whose number is 20, the number of 40, the number of 60. And I do that for all the high schools and just randomly pick them out that way. Okay. If we're doing Utah, maybe you do something like you randomly pick um, 10 big schools, 10 medium schools, and 10 small schools. And out of the big schools, you randomly pick every 20th senior. The medium ones, you pick every 10th senior. And here you pick every uh, third senior. Or you could just randomly pick a number out of the hat and say, student number 27. And then you pick another random number out of the hat and be like, student 3. And then you pick another random number out of the hat, student 98. And you have to be like, okay, these ones have 800 students, these ones only have 400, these ones only have 200, whatever. And you choose until you get 10 students from each one, okay, from each of these 10 big schools. And then, so you do something like that, and then you do the same thing probably for nationwide as well. So you'd want to make sure it's very random. You assign each student a number and you just randomly draw that number out. You do it every 20th person, every 10th person, whatever. That's systematic, okay? Some way to make sure you're not choosing the high or the low or the ethnicity or whatever. You're just randomly choosing a number, and it doesn't matter who that person is, and ethnicity, nothing. It just says, here's this person, and here's our GPA. So anyways, the next one, explain why the 1936 Literary Digest poll about the presidential race between Roosevelt and Landon produced such biased results. So if you read in chapter 9, section 1, it talks about this poll that they did. But the Literary Digest it only polled the society members that were more rich. Okay, so it only polled people of the upper class. Well, Landon was more of an upper class guy, whereas Roosevelt was an everyday person guy. And so when that poll came back, it said, oh, Landon's going to win by a landslide, because all of these upper class people are like, hey, this is the guy, But all of the working and all of the people that weren't upper class were big fans of Roosevelt. And they're like, this is the guy. And it was actually Roosevelt that won, and not Landon, as you've never heard his name as part of our presidents. So anyways, that's kind of what chapter 1 is about bias, about how we can try to create data without create a sample without introducing bias into it and getting they call it clean versus dirty sample, but get a sample that is actually truly representative of what we're trying to look at. Okay, and we really want it to be unbiased, and we really want it to be random. Okay, in order for it to truly make accurate results and accurate predictions, it must be unbiased and it must be random. Okay, and this systematic, that is random. You know how I said every 20th person, that is random, because we aren't saying, we're just randomly saying every 20th person, that person, that person. We're collecting it from every one of them. So it needs to truly be random to work great, and that kind of thing. So reading chapter 9 verse or section 1 would be a pretty good idea to help further your idea of this chapter. But anyways, it kind of has some interesting ideas, and some of it gets a little bit deep, but for the most part, it explains bias and some other things pretty well.